So, welcome back for the 6th week of this course. So we had already started our discussion on what is parsing. So, this is the topic in syntax, and we talked about the constituency parsing approach, okay, by using the probabilistic context free grammars. So, now we will use a slightly different notion of parsing. It's called dependency parsing. So, where instead of what we did in the case of constituency parsing, where we were finding out what are the different word groups in terms of noun phrasage, adjective phrasage, verb phrasage, we will directly find out what is the relation between any two words in a sentence. Okay. So, dependency parsing notion has picked up a lot in research field in the last few years, but as such its origin is very old in many different linguistic traditions. For example, for the Sanskrit, the famous Sanskrit grammar Pani Jashadhyai, Pani defined these Karaka relations, that are the dependency relations between verb and different words in the sentences. So, for example, if I have a sentence like Ram eats apple, a simple sentence, I will say the verb eat is the main verb here, and what is the relation of Ram? So, Ram is a subject of this verb and apple becomes an object of this verb. Okay. So, like that here I am trying to directly say in this sentence, if I have different words, are these related somehow, and what is the relation between them. So, this is my dependency structure. So, in this lecture we will see what is the formal way in which we can define dependency structure, what are the different linguistic constraints etc. that we need to impose on the structure, and then we will start talking about some of the models that are very popular for getting the dependency structure started from the sentence. So, this kind of tree we have seen in the case of phrase structure, also called the constituency structure. So, what we are seeing here, I have a sentence, economic news had little effect on financial markets. So, they are different group of words that act as a single unit. So, economic news make a noun phrase. Similarly, this whole thing makes a verb phrase and they together make a sentence. So, like that what we are seeing here, which words are grouped together, okay, and how this whole sentence has been arranged. That is what you see in a phrase structure. Now, how is dependency structure different? So, for the same sentence, let us look at the dependency structure. So, here what are you seeing? Now, this also looks like a tree, but the nodes here are the words themselves, not the phrases, and different words have been connected by some edges and they are labeled by some relation, like had and news are connected and the relation is subject, saying that news is a subject for the verb had. Similarly, economic and news are related. So, this is economic is a noun modifier for the word news, and so on, a lot of different words are connected in this sentence. So, in general what we are seeing, two different words in a sentence are connected by certain relation, and this is a directed sort of relation. So, economic and news are related by saying economic is a noun modifier for news. So, in general how we can define a dependency structure. So, we take another sentence here, he sent her a letter. Okay. So, what you are seeing here? So, first you are seeing some 5-6 words also if you take the punctuation. So, there are 5 words as such, he sent her a letter, 5 individual words. So, what do we do in dependency structure? So, we are connecting the words in the sentence by putting arrows between the words. So, I am putting an arrow between sent and he, and these two are connected. So, he is a subject for sent. Similarly, I am putting an arrow between sent and her, saying that her is an indirect object for sent. Now, what do these arrows show? These arrows are showing me the relation between words and are also tied by some grammatical relation. So, they are saying there is some relation, and what is the relation? It is a subject relation. He is a subject for sent. And what do these arrows connect? They connect a had word like sent with a dependent word like he. And there are some, in linguistics there are some other terms like had can be called a governor, superior or regent, and the dependent can also be called a modifier, inferior or subordinate. And usually, as you would see, the dependency will form a sort of tree structure. Now, so what is important here? So, in dependency you have a head that connects to a dependent by an arrow. So, arrow points from a head to a dependent. So, now are there some formal criteria for saying in a sentence if two words are connected, what will be a head and what will be the dependent? So, there are some criteria, they may not be applying everywhere, but may be applying at certain points. So, we will see some examples for some of these. So, what are the criteria for defining a relation between head and dependent in a construction? So, first criteria you can see is that the head determines what is the syntactic category of the dependent, or sorry, what is the syntactic category of the whole construction. Okay. So, like if I see this construction a letter, the whole syntactic category is governed simply by the word letter. Okay. And that is why the head itself, so the word letter becomes the head, and this word letter can also replace the whole construction C. So, in place of the whole thing a letter, I may also write simply letter. Now, D specifies H. So, that means D is giving further specific information about H. So, if I say only letter, it may not be as specific as saying a letter. Okay. So, all these determinants, they give some additional information. Similarly here. Okay. So, sent is the head and letter is the modifier. So, if I just simply say he sent, it is not very specific. To whom did he send? So, there I have to specify the particular modifier. He sent her. Similarly, what did he send? So, there I have to put the word letter. So, what you are seeing? The dependent is further specifying my head. Now, in some cases, so head is always obligatory. I need to put head, like letter is necessary to put, but D I may put it optionally in some cases. So, I may also say he sent her letter. Okay. So D, the dependent may be optional in certain cases. Now, the head word, it selects my dependent D, and it also determines whether the dependent is obligatory or not. And in some cases, the form, the grammatical form that D takes will also depend on my head. So, this is also called the agreement or government in the case of linguistics. So, that so like the form that you use for your verb in your construction will be similar to the form of the subject and object that you are using. Also, that the linear position of the dependent is specified with respect to the head H. So, for example, so English follows this SVO construct, right. So, you get the subject first, then the verb, then the object. So, what we are seeing, the linear position of the dependent is determined with respect to the head. So, if I know the verb has come, so I know subject will come to the left and object will come to the right. Like I want to say a sentence where I am saying I am eating something. So, who is eating? The subject will come on the left, I eat, and what do I eat? Say an apple, that will come on the right. So, the position of the dependent is specified with respect to the head, whether it is to the left or to the right. Now, there are some cases that are clear where you can easily find the dependencies. So, for example, if I look at the exocentric and endocentric constructions. What do we mean by endocentric and exocentric? So, endocentric construction is one where one of the entity here can actually fulfill the whole grammatical function of the complete construction. So, if you look at this verb and adverbial relation, verb modifier. So, what is the example? Certainly affected. This is doing some grammatical function, certainly affected. And why it is endocentric? Because only one word here, like affected, can fulfill the whole grammatical function for the whole construction, certainly affected. Certainly is simply modifying that. Same way for non-modifier, like financial markets. So, markets can fulfill the grammatical function for whole thing, financial markets. This is not the case for exocentric construction like verb and subject. So, if I take affected and used. Affected cannot fulfill the whole grammatical function for used and affected. I need to have the word used there. So, this is called exocentric. Endocentric, one word can fulfill the whole function, exocentric, a single word cannot. But the cases are very clear in what will become the head and what will become the dependent. Like if I have the verb and subject, I know that verb will become the head and subject will become the dependent. Same with verb and object, verb becomes the head and object becomes the dependent. In the case of endocentric again, the particular word that can fulfill the whole function can become the head and the other word can become the dependent. So, here verb is the head affected and suddenly becomes the dependent. Similarly, here markets is the head and financial becomes the dependent. Now, if you just try to compare what is the difference between a phrase structure representation and a dependency representation, what do we see is that in phrase structure we are very explicitly denoting what are the phrases, these non-terminal notes and labels. In the case of dependency relations, what are we explicitly denoting? There are words, but what are the relations between different words and what is the grammatical category of each individual relation. So, in the case of phrase structure, I denote what are the phrases and what are the structural categories like noun phrases, verb phrases and so on. In the case of dependency structure, what do I represent? What are the various head dependent relations like in the case of directed arcs, and what are the functional categories, that are what are the different arc labels that I am giving to various arcs in my dependency relation. Now, formally can I define what is dependency graph? So, I have to define it for the words in my sentence. So, formally I can say that a dependency structure can be defined as a directed graph consisting of a set V of nodes and a set of A of arcs. Now, this is a very general way in which you define a graph. In a graph, you have a set of nodes and set of edges that are connecting different nodes. Now, is there something more than this in the case of dependency structure? Now, in the case of dependency structure, so these are labeled graphs. So, what are the nodes in my graph? The nodes in the graph denote the word forms, the words that I am encountering in my sentence, and with that I might also have some annotations like what is the part of speech category of these words. This I can also put in my notes. And what are the edges? They are labeled edges with the dependency relations. What is the dependency type? Is it a subject, object, non-modifier, verb modifier, etc. And some simple notations that we use for this is that if I am saying that word wi is connected to word wj with the dependency relation d, I can use this arc wi d wj. It says that wi is the head, wj is the dependent and d is the relation. Okay. So, I can say eat subject and I or he. Okay. There is another way in which I can denote the arcs by saying this is the head word, the dependent word. I am denoting a arc from head word to dependent word and then putting a label on top of that. This is another way, okay. And this is equivalent to saying wi, d, wj are in the set of arcs. There are some other conditions like if I say that from I there is a relation from I to j, direct relation, then I can write that I j is in my set of arcs. So, I am not writing the dependency relation here, but I am saying I and j are in the set of my dependency relations. Similarly, I can do a closure of this saying that I from I there is a path to j. Okay. So, that means in any number of steps I can go from I to j. If and only if either I and j are equal or there is some case such that I go from I to k and from k you can go to j in any number of edges. This is simple, this is a very standard way in which we define the closure relations. So, with the dependency labels I can define a single dependency or I can also define a closure of that. So, I hope this notation is clear. So, once we have this notation, what are some of the formal conditions that we can put on the dependency graph? So, on the graphs, so that they denote a dependency graph for a sentence. What are the formal conditions? So, what are the formal conditions? So, the first condition is that the dependency graph that G that I get is connected. Okay. By connected, what do I mean? There is no node in my graph that is isolated from the whole graph, or in other words, if I take any word in my graph, any node in my graph, I can always find another node such that either that node has an incoming link from the previous node or an outgoing link to that node. Okay. So, it is connected to some of the node in the graph at least, it is not isolated. So, this is a simple condition for saying what when a graph is connected. The second condition is that my graph is acyclic, there is no cycle in the graph. So, what do I mean by that? If I say that from a node I have a label, I have a path, or I have a dependency from I to j, there is no way I can have a path from j to I. So, there is no way I can go back to I. If I am going from I to j, I cannot go from j to I, either directly or by following something k and this. So, this is not allowed. Okay. So, because this will make a cycle I to j, j to k, k back to I. So, the cycles are not allowed in the case of dependency graph. Similarly, if I can show the previous one, that means that if I take a node I in my graph, it should not happen that they are connected and I is isolated. I can always find some nodes such that either there is an incoming edge or there is an outgoing edge, one of these. They cannot be both, right, because of this principle of acyclicity. What is the third one? Third constraint says that my dependency graph G obeys the single head constraint. So, what is single head constraint? So, single head constraint means that if I take a node I in my graph, there can be at most one head for that. Okay. So, if I say that j is the head for I, so j is the head for I cannot find another k, so that k is also a head for I. This is not possible. There will be only one head for a node at most. This is called the single head constraint. And then finally, I have the fourth constraint, that is G is projective. It says if from I can derive j, and from j, so I am using the word derive here, derive means from I is the head and I have a dependent j, then from j I have a dependent by some number of edges k for any k such that j k lie on the same side of I. Okay. And this is the projectivity constraint. Now, what do I mean by that? If I have an edge from I to j, and from j I can have in any number of steps I am going to k, then j and k should lie on the same side of I. So, that is if I am saying this is my I, and from here I have this relation to node j. Okay. Let me just project them, I is here, j is here. Okay. Then what am I saying is that if j connects to any dependent either directly or indirectly, that k has to be on the right hand side only. So, there are two possibilities. Suppose I am taking direct connection, I can connect to k, this is allowed, or I can connect to a k here. Okay. So, this denotes the linear order in which they are occurring in the sentence. So, I and j are here. So, k can occur either here or here, okay, or anywhere else in the right. But what is not allowed is if j is related to some k here, that is not allowed. because now j and k are on the different side of I. Okay. So, whatever side j is, k also should be on the same side. And if this situation happens, this is called non-projectivity. Also, there is another term for that, it is called crossing of dependency edges. So, you are seeing here this line and this line are crossing here, if I am taking this particular construct. While they do not cross, if I take this construct or this construct, and you can see if you can go in any number of steps, they will not cross. Okay. And this particular constraint is called the projectivity constraint. Now, what is important is that this constraint of projectivity is many times dependent on the particular language that you are choosing for your dependency construction. So, it might happen that there are certain languages that do not follow this projectivity constraint, and some languages like English, they quite regularly follow this projectivity constraint. So, this is like language dependent. So, the methods that the dependency parsing methods that we will study in this week. So, we will study one method that needs this projectivity constraint, another method that does not need this constraint. Okay. So, but yeah, these 4 constraints are very important, so that you can come up with a good algorithm for the dependency parsing of a sentence. So, yeah, this is an example of what is projectivity. So, if I have a link from A to B, I cannot have a link from B to C, because C is on the other side of A. Similarly, I have a link from A to B, I cannot have a link from B to C, okay, because they are crossing now. In general, what do they mean, these 4 conditions? So, connectedness means that the syntactic structure that I am obtaining by my dependency graph is complete. I am not having any isolated nodes that are not connected to my whole structure. Second condition of acyclicity means that the structure is hierarchical, there are no cycles inside. What is the single head constraint? It says that every word has at most one syntactic head, it cannot have more than one syntactic heads. So, or in other words, you are saying that it is determined only by one word, not by multiple words, right. Remember, we were saying that the linear position of a dependent sometimes depends on the head. So, you do not want 2 different heads to decide the position of a single word, and then there might be conflicts. So, same word has only one head that determines its syntactic category and other things. There is no crossing of dependencies, that is the last constraint of projectivity that we also saw. So, now once we have these 4 constraints, what is my dependency parsing? So, this is how I can define my dependency parsing. I am given a sentence X that contains words W1 to Wn, and I want to obtain a output as a dependency graph. Given this input of sequence of words as my sentence, I want to obtain a dependency graph that follows the constraint that we saw earlier. Okay. So, it is like single head constraint and projectivity if I am imposing that and all that. So, I want to obtain a dependency graph. So, now what are the different methods that we will be using for this? So, we will talk about different methods. So, like one method will be deterministic parsing, this is a very popular method. Then a method based on maximum spanning tree, and finally, you can also do it in a constraint propagation method. So, in this course we will talk about the first 2 methods and how you can use that by having some sort of label data and doing some learning from there. So, it is like a data driven parsing, and the final method is something that you will use when you do not have any label data, but you know what are some of the constraints that your grammar follows. So, can you encode those constraints inside your dependency grammar and obtain dependency graph for a given sentence. So, this is good for the languages where you do not have the label data, but you have the label data in terms of dependency graphs, you will probably go for a data driven approach. So, starting from the next lecture, we will start talking about these data driven approaches for dependency parsing.